Now let's move on to compounding. But before we do, there's an important function in the BA2 Plus that allows you to change the number of decimals that are shown. When you actually calculate something in this calculator or many other calculators, it has a floating point decimal place that will collect, I think, at least 9 decimal places, in some cases more. In this class, I want you to round your final answer to the nearest penny, but to avoid this rounding problem that can occur in multi-step calculation problems, we want to keep the number of digits out to 4 decimal places. So in order to do this, we want to hit the second key and then come down here to the format button or the decimal place button. And it'll say DEC equals, and this is where you want to hit 4, enter, and then to get out of that function we hit second and quit. Now we can see that it shows 4 decimal places, and you can show more if you'd like, but I think 4 is sufficient. Okay, compounded interest. So in the last section we did a problem where we looked at one period of interest. What happens when money is left in the bank account for more than one period? Well, then we see the effects of compounding because you get to start to collect interest on the interest. So you deposit the $100 in a savings account. It pays 6% per year. What amount would you have in this account after 2 years? Or what is the future value of the $100 at 6% after 2 compounding periods? So you can see how the timeline has changed. We've simply stretched the timeline from 1 period to 2 periods. So in this calculation problem, we would collect 100. We'd have the $100 invested. We would collect $6 in interest the first period, but then we see the second period we would add another 6%. The 6% would be compounded not just on the original $100, but it would also be compounded on the $6 in interest that you collected previously. So we have $100 times 1 plus the interest rate as a decimal, raised to the number of compounding periods. So rather than getting just 2 periods of simple interest, we get 2 periods of simple interest plus 36 cents in compounded interest. Let's use the calculator to calculate the same thing. So just like the previous problem, we want to make sure that the time value of money functions are clear. There's nothing left in our registry. I already know that my payments per year is set at 1. Once you've done that, you don't need to do it more than once. Now we can enter in our values. So we have 2 compounding periods, or in this case 2 years. We have an interest rate of 6%. We have $100 invested. I'm going to make it negative, representing an outflow. And then we can hit compute future value. So we get $112, the $12 representing the simple interest collected on the investment, and then the 36 cents is that 6% of compounded interest on the original. So there's an interesting relationship between the number of periods, the future value, and the interest rate. We can see that the higher the interest rate is, the faster the interest collects. That seems fairly intuitive. Also, the number of compounding periods as they increases the future value. That also is fairly intuitive because we would collect interest on interest on interest as well as the simple interest that is collected. But what's not so intuitive is the fact that these relationships are not linear. We see that there is a curve in this line. This curve is the effect of compounding interest. It's that idea that I'm getting interest on my interest after the first compounding period. So the key points here, the greater the interest rate, the bigger the return, the bigger the future value. The longer the investment is held, also the bigger the future value. There's a direct relationship between both of those. Now, an important but subtle point is which factor, return, or time has the greatest influence on the future value. To understand this, we need to go back to the present value, future value equation. And we can see here that time is in the exponent. So as I increase my time, let's say that I had a choice between either doubling my interest rate or doubling my time. let's run that example problem here. So I'm going to clear time value of money. And the first one, I'm going to double my time. So I'm going to have 4 periods, 6%, $100 invested. And we compute our future value. So my future value would be $126.24. Now let's go back, do the same calculation, but let's double the interest rate rather than doubling the time. So we have 2 years at 12% with the same $100 invested. We would only amass $125.44. Now that's roughly a little less than $1, which doesn't seem significant. But compounded over many compounding periods and a long time, that is a significant difference.